All right. Writing numbers in scientific notation. We talked about this yesterday. We actually did it with these last two examples. We spent most of the time, however, talking about how to turn a number that's written in scientific notation into standard form. And now we're going to go standard form to scientific notation. So there are two steps. Place the decimal after the first non-zero digit. So in the case of the Google problem, YouTube, it was after the 1. In the case of the Indonesian earthquake, it was after the 2. That'd be the first non-zero digit. Okay. Step number 2, count the number of times you'd have to move that decimal back to its original location. If you end up moving the decimal to the right, or if you have to count to the right to get back to that spot, then that's going to be a positive exponent. If when you place your new decimal, you end up counting to the left, I guess this would be your guys' left, wouldn't it? Yeah. Then you would have to put a negative exponent. So where do I place the decimal? Owen, you have a question? No, you have to write times 10. That's what Xander asked yesterday. You got to write times 10. Your graphing calculator will put the E, okay? But that's not the actual scientific notation. It's just how the calculator represents it. It says, write each number in scientific notation. Where do I put the decimal, Oliver, in the 25 million that we have here? After which digit? Not after the 5, the 2. If you put it after the 5, then it'd be 25. And remember how we said yesterday, it has to be between 1 and 10? Can it be equal to 10? What do you guys think? Can it be equal to 10? No. Can it be equal to 1? Yeah, because that's 1 digit. So, oops, there you go. It can be greater than or equal to 1, but it has to be less than 10. So we have to put the decimal after the 2, which makes it 2.5, which does fall in that range of 1 to 10. Then we're going to multiply by 10, and we're going to count how many times it would take us to get it back to its original spot, which is obviously at the end. So 1, 2, 3, 4, 5, 6, 7 times 10 to the 7. Sky, where would I put the decimal in example B? Okay, so 5.06. And then Sky, what direction am I going to count? Left. And how many? So what's my exponent? -4? Got it. All right. Next one. It's a lot of zeros. Jacoby, where do I put my decimal point? I like how you specified after the first 3. That's going to make it 3.3. It's between 1 and 0, or 1 and 10. And then, Jacoby, how many times would I have to move it to the left? Okay, and do I write positive or -9? That's right. Now, what common mistake I'll see on your quiz, on your test Friday? I'll get this. That is not the same number. Times 10 to the -9 is the same number. This is going to sound odd, but I've had students, when I ask them to write their answer in scientific notation, they've written this, and then they must have had something, I don't know, some sort of brain fart. They look at it and they go, oh, I must need to multiply that out. Guess what answer they get if they multiply 3.3 times 10 to the -9?
The same number.
They get the number they started with, and I'm like, what are you doing? You didn't write it, you put it back in standard form. We don't want to write it in standard form here. We want to write it in scientific notation. So you are done when you get to this step. Okay. Yeah, it is the same value. They're the same, just 2 different ways of expressing that number. And then example D, 683. Not sure why you'd want to write this in scientific notation, but we can. Lizzie, where would you put the decimal point? Okay, so 6.83. And then would I have to move the decimal to the left or to the right to get it back to its original location? How many times?
Twice.
Times 10 to the positive or -2? And that makes sense, because what is 10 squared? 100, and 6.83 times 100 is 683. Yes. Sure. An album receives the Diamond Award when it sells 10 million copies. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive the Diamond Award? Write your answer in scientific notation. Well, how do I figure out how many more they'd have to sell? Christian? Subtract. Okay, subtract the 8,780,000 from 10 million. And how many does that leave left that we'd have to sell, Christian? Okay, and then we'd have to write that in scientific notation. Lucy, you want to give that a shot? Where would I put my decimal point? After the 1, so we'll write this as 1.22. Don't write the extra zeros. That defeats the whole purpose of shortening the number. And then if I put my decimal point after the 1, Lucy, would I have to move it to the right or to the left to get it back to its original location? Yep, because it's just over there at the end. And how many times would I have to move it? That's right. So 1.22 times 10 to the 6th. Remember, commas aren't numbers. So don't like count twice when you go around a comma. Match each planet with its distance from the sun. Then write each distance in scientific notation. Is it easier to compare the numbers in scientific notation or standard form? Looks like I put SN for scientific notation. One, two, three, four, five, six, seven, 8. Where's Pluto? This must not be from my high school or middle school science book, because Pluto was a planet back when I was your age. Okay, so I'm going to change the instructions a little bit, because I'll be very honest with you. It's actually easier to tell which number is greater when you write them in scientific notation. Okay, so why don't we write these all in scientific notation? Then maybe we could match them with the planets. That might be easier here. So planet A is 1,800,000,000, I want to say miles, kilometers, miles. I don't know if it says. So we'll just assume it's miles, I guess. Maddox, give me that number in scientific notation.
1.8.
That's right. Yep, to the power of 9. You got to move it 9 times to get to the end. Okay. Example B. Shane, tell me what this number would be in scientific notation. Times 7. 10 to the power of 7. 1, 2, 3, 4, 5, 6, 7. I'd have to agree. Now, can you tell me which of those is bigger? Obviously, in standard form, we know which one's bigger. Can you tell by looking at the scientific notation form which one's bigger? How can you tell, Sky? Oh, yeah, that has a larger exponent. Exactly. So you know which one's larger. Okay. Example C. Give me that one, Alex, in scientific notation. That's right. Times 10 to the 8th power. So you're going to put your decimal right there, and you're going to move it 8 times. Deegan, give me example planet D. Should say 93 million. What would that be in scientific notation? 9.3 to the power of 7, like this. Yes. There we go. Times 10 to the power of 7. Okay. Seth, what about E? Not to the power of 7. Count with me here. 1, 2, 3, 4, 5, 6, 7, 8 to the 8th power. There you go. Times 10 to the 8th. Connor, what about planet F? That's right. 2.8 times 10 to the 9th. Okay, planet G, Lucy. To the 8th, 1, 2, 3, 4, 5, 6, 7, 8. Good job. And then Martin, what about planet H? All right, 3.6 times 10 to the 7th. It's going to be much easier to match up the planets now because I know the ones that are the closest to the sun are going to be the ones that have a power of 7. The ones that are in the medium range, power of 8, and the ones that are farthest are a power of 9. So let's look first only at the ones that have a power of 7. Which of those is closest to the sun or smallest? Julia? H, and H must be what then? Mercury. Okay. And after Mercury would come B or D? Jane? B, and that must be Venus. And that must mean Earth is 93 million miles away from the sun. Okay. Now let's look at the planets that are raised to the 8th power. That's C, E, and G. Which of those is the least now? We know they're bigger than the other 3, but which of those is the least, Christian? E, and what would E have to be? Mars. Good. That one's gone. And then the next smallest one up there, Owen, which one? Is it C or G? G, okay. And so what would come after Mars? Owen, what comes after Mars? Picture of the planets. No. Look at the picture. What planet comes after Mars? I'm getting farther and farther from the sun. Jupiter. Yes. Jupiter. I believe I've heard that Jupiter is 100 times larger than the Earth, to give you an idea of just how big it is. Could be mistaken for another sun, but it's not a star. So. And then after Jupiter, that must mean the last one here is Saturn at 8.9 times 10 to the 8th, or 890 million miles away. And then we have 2 that are to the power of 9, planet A and planet F. Which of those 2 is Uranus? Sorry, Uranus. That's less offending to you. Christian? A, yes. Uranus. Sorry, Uranus. Uranus. I had a game, like a solar system thing, and you like press it when I was a kid. I remember pressing it, tell you the planet, and tell you facts about it. And the guy always pronounced it Uranus. I'm like, is that how you really say it, or is that just how you want to say it so you don't get made fun of? I'm still not sure.
Why? So you're not pressed up on.
Which means Neptune is the farthest from the sun at 2,800,000,000 miles, or we might say 2.8 times 10 to the 9th. And that is all 8 planets, since Pluto is, I guess, orbiting some other star. Must have been a, I don't know, what they say is a dwarf planet? And that's not a planet then?
Well, it's because it's like it doesn't fit the actual characteristics of a planet. There's certain like guidelines and something that's supposed to be considered a planet. People realizing going to recent studies that that like that planet, Pluto, doesn't actually fit into it correctly, so they classified it as a dwarf planet.
It would be a good one to do up Neptune.
Yeah.
I kind of liked it when it was just a planet. Nobody really said anything. Why does it matter?
Because
What kind of has more to do
because
with
then
its
like a bunch of other dwarf planets could be considered a planet.
That's true. I wouldn't want to add to the list by any means. So, okay. This table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. Now they're in scientific notation, so this will be pretty easy to do. Which of these was the most recent, meaning the smallest number of years ago? Dawson? Cenozoic. Yeah, that would be the most recent. So I'll label that 1. Okay, then it comes down to the 2 powers of 8. And Jimmy, which of those is the next most recent? Mesozoic. Okay, and that leaves the Paleozoic as the farthest on this list. What about the Jurassic? It's coming out soon. The Jurassic World Part 3, the end of the Jurassic World trilogy. Had a real good beginning, a mediocre middle, and we'll see how it ends. You could say the same thing about the original Jurassic Park trilogy. Really good first movie. Second one stunk. Third one was okay. Yeah. Okay. And then finally, we're going to do some more comparing. It says in chemistry, pH is measured is a measure of the activity of dissolved hydrogen ions. Liquids with low pH values are called acids, and liquids with high pH values are called bases. And right in the middle, you have distilled water, which has a pH value of 0, okay, or neutral. Actually, I shouldn't say it's 0, it's just neutral. Distilled water, there it is, 0.00000001. It says, find the pH of each liquid. Is the liquid a base? Is it neutral? Or is it an acid? So how do I write 0.01 in scientific notation? Xander.
1 times 10 to the negative second power.
That's right. So you put your decimal after the 1, and you'd have to move it left twice to get back to its original location. And therefore, times 1 to the negative second. Xander, is lime juice acidic or basic?
Acidic.
It is acidic. Yes, you'll find the 10 to the negative 2 down here. So this is an acid. In fact, it's actually used in a lot of cleaning supplies. They put like lime juice in that, make it smell that a little bit better, I guess. An egg. How do you write 0.00000001 in scientific notation? Chloe? That's what I got. Yep, 10 to the negative 8. I totally agree with that. So Chloe, where would you find that on this scale? Is that going to be a base or is it going to be an acid? Barely a base. Yes. Distilled water, I've already told you, is neutral. You can write it as 1 times 10 to the power of negative 7 when you count backwards 1, 2, 3, 4, 5, 6, 7 times. Okay, so it's neutral. Then you've got ammonia water. Ammonia water. Jace, how do you write that number in scientific notation? That's what I got. Nice job. To the power of negative 11. And Jace, does that make that a base or an acid? Yeah, definitely a base up there in the blue section. Tomato juice. Tomato juice. Emerson, how do I write that in scientific notation? Either. Okay. It's the power of negative 3. So 1, 2, 3. Okay, 4. Gotcha. All right. That is much better. I was worried you were going to leave it as 1 to the negative 4th power, which actually is still 1 because 1 to the negative fourth power would be 1 over 1 to the positive fourth power, which is still 1. Yeah, so good. 1 times negative 10 to the negative fourth power. Remember, negative exponents don't make your answer negative. They just make it smaller. And so Emerson, is this going to be a base or an acid? Going to be an acid?
Yeah.
You are correct. Yeah, this would be an acid. Okay. Next up, we have hydrochloric acid. Carson, do you think this is a base or an acid? Probably an acid. How would you write 1 in scientific notation?
Should it just be like 1 times 10 to the power of either 1 or 0? Probably 0. Because the decimal.
That's right. Yeah, the decimal point goes there. You wouldn't move it at all. So it's the power of 0. That's exactly right, which means it is as acidic as you get. Definitely an acid. All right, that's it. So I'll stop the video and then we can go over homework questions. And for those of you who don't have any homework questions, start your IXL.